Welcome to section 9.1, day 1, quadratic functions. Today's objective is to know the characteristics of a quadratic graph of the form ax squared plus bx plus c. All right, a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. And if you recall from earlier this year, the y can also be written as f of x. So sometimes you'll see this written as f of x instead of y. And this is called the standard form of a quadratic function. In this expression, on the right side of the equal sign, the ax squared plus bx plus c, the a, b, and c are called the coefficients of x. Because a is the first coefficient, we call it the leading coefficient. We've talked about this previously this year. C is the constant. It's just a number. And c is also the y-intercept. So when you graph this, if there's a number at the end, it tells you where you cross the y-axis. And if there is no number, then the y-intercept is at the origin. Here it states to list the coefficients of each quadratic equation. So we want to be able to pull out the a's, the b's, and the c's throughout this chapter because we use them in certain ways. So in this case, we have a equals, well, it's the leading coefficient. It's just negative 17. Make sure when you pull these a's, b's, and c's out that we are already in standard form, and the one above is in standard form. We are going from highest exponent down to the constant. The b is just the 36, and the c is our number at the end, the constant, which is negative 19. For the second one, you'll notice it is not in standard form, so we need to get the y by itself and move our 2. So we add 2 to both sides, and we get y is x squared minus 5x plus 2. Now we can identify our a, b's, and c's, and our a, even though it's not written, there is technically a 1 in front of the x squared. We've done this throughout the year. For the b, we have negative 5 as our coefficient in front of the x variable to a power of 1, and the c is the constant, which is 2. So we need to be able to do this because we will require us to use these coefficients when we use certain formulas throughout the chapter. The graph of a quadratic equation is called a parabola. This is a term you need to know. We'll be talking about parabolas the rest of this year. You will see them again in college prep algebra and other classes that require math and physics and science. Parabolas are U-shaped. Parabolas are symmetric. The two halves of a parabola are mirror images of each other. And if you go way back to chapter 1, we talked about lines of symmetry. We will do that again as we go through this lesson today. If the leading coefficient of a quadratic is positive, then the parabola opens up. So when you had our last slide, we had y equals x squared minus 5x plus 2. Remember that was a positive 1, so this one would open up. The other one we had on the last slide was y equals negative 17x squared plus 36x minus 19. And because we have a negative 17, that one would have opened down if we graphed it. So if the leading coefficient is positive, we open up. It means we can fill it with stuff. It's like filling a coffee cup. And if it's open down, that means we can't fill it with anything because all the water would drain out. That's another way to look at it. So positive is up, negative is down. So the vertical line that divides the parabola into two symmetric halves is called our axis of symmetry. The axis of symmetry also passes through the vertex. And we're going to talk about the vertex more on the next slide. So to find the axis of symmetry, if we're just given the equation, this is where we need to know what our coefficients are. We take that x, the line of symmetry is a vertical line, and vertical lines are written as x equals some number. So the equation for finding the axis of symmetry is x equals the opposite of the b coefficient over 2a. So below we have find the axis of symmetry for the parabola y equals negative 2x squared plus 8x plus 1. To find the axis of symmetry, we are just going to plug in the b and the a. Well, our b is 8 and the a is negative 2. We're going to plug these into our formula. X equals the opposite of b, the opposite of 8, so negative 8, over 2 times, in this case, our a is negative 2. Okay? Then we simplify. We have negative 8 over negative 4, which is just 2. So we write this as our axis of symmetry is x equals 2. And we will say this. And you can abbreviate axis of symmetry to AOS. So we find the axis of symmetry, we want to label it. Axis of symmetry is this line, x equals 2. And if we have a parabola and we're going to draw the axis of symmetry, we will actually draw it as a dashed line through x is 2. We always write the axis of symmetry as a line equation, x equals. Don't forget that. Always write it as a vertical line equation, x equals the number. The vertex is the highest or lowest point of a parabola. Notice our first bullet says the vertex is an ordered pair. Because it says that the vertex is a point, it is our highest or lowest point. Points come as ordered pairs. The x value of the ordered pair is found by using the equation for the axis of symmetry. Sometimes you will see the same formula, this axis of symmetry formula, called the vertex formula, because we use it to also find the x coordinate of the vertex. The y value of the vertex is found by substituting this x value back into the original equation. So we find our axis of symmetry, x equals something, which is our vertical line. We can take that x value and plug it into the original quadratic equation and solve for the y value of the vertex. So remember from the last slide, when we did this, we found that x equals 2. So we can plug this in now and find out what y is when x is 2. And be careful when you do this. Put what you put in parentheses so you do not make any mistakes. So we have negative 2. We always have to do our exponent first, so 2 squared is 4. So now we have negative 2 times 4. I'm going to leave it separated right now. 8 times 2 plus 1. And then we have negative 2 times 4. I'm running out of room, but we'll squeeze it in here. We get negative 8. 8 times 2 is 16. Plus 1. So we have negative 8 plus 16 plus 1. This becomes 9. So our vertex is the point 2, 9. And we will state this way. Our vertex is this. So we're going to say vertex and we give an ordered pair. The next thing we're going to talk about is minimums and maximums. If the parabola opens up, if it has this shape, our vertex here is down the bottom, and we have a minimum point on the graph because all the y values are at the vertex or higher. If the parabola opens down, we have it looking like this, and our vertex is at the top of the hill, and all the y values are below. So this is a maximum y value. All the other y values are less than it. So here it says for the equation y equals 2x squared plus 12x minus 3, find the axis of symmetry, then find the vertex, and then state whether we have a minimum or a maximum. So first, the axis of symmetry. Remember, that is the equation x equals the opposite of b over 2a. Here we have our b is 12. We want the opposite of that, so negative 12. And we have 2 times our a value of 2. And this gives us negative 12 over 4, which is 3, or negative 3. So our axis of symmetry is x equals negative 3. That's our first part. This is my AOS. Then we need to find a vertex. We're going to plug -3 back into our quadratic equation we're given. So we have 2 times -3 squared plus 12 times -3 minus 3. -3 squared is 9, so 2 times 9. I'm going to leave all the multiplication for later. Do our order of operations. And then we have 2 times 9, which is 18. We have 12 times -3, which is -36, and minus 3. And when we take 18 minus 36 minus 3, we combine them all together, we get -21. So our vertex is the point -3, -21. That's our second piece. The last thing that it says is tell whether the vertex is a minimum or a maximum. Remember, our A is 2, so this is greater than 0, so we are opening up. If we were to graph this, it would have this shape, and our vertex would be down way below at -3, -21. It opens up. This means this is a minimum point, because our vertex is at the bottom of the graph, everything else is above it. It is a minimum. That can be confusing, that up is a minimum and down is a maximum, so try to keep that straight. And if you need to draw the picture of it, just a real quick sketch what up means or what down means, it will help you say if it's a maximum or a minimum. The last thing we're going to talk about are the zeros of a quadratic graph and the y-intercept. The zeros, also called roots, are where the graph touches or crosses the x-axis. We've talked about zeros earlier this year. We did it back into chapter 4, chapter 5, where we found zeros. So in this case, we're going to say, what is the y-intercept? And I talked about this earlier. The y-intercept is just where it crosses the y-axis. And in this instance, our y-intercept is -3, or you can write it as a point, 0, -3. The zeros are the two places where it crosses the x-axis in this case. So we have our x values, and it crosses at -1, and it crosses at 3. And these are my zeros. When x is -1 or x is 3, we get our result back of y equals 0. That's why they call it the zero. If we were given this function up here, you'll see if we plug this in, x is -1, the y is 0, and plug in 3, the y is 0 again. The vertex for this is this lowest point down here, and we are at 1, -4. Remember to write that as an ordered pair. The axis of symmetry is the line that goes to the vertex. It's the vertical line that cuts the graph in symmetric halves. So our axis of symmetry I just drew in there goes through x equals 1. And we do write this again as a vertical line equation. All right, so there's the last piece, the zeros and the y-intercept. So one more slide to go. Putting it all together, we are given this function, and it's y equals -x squared minus 2x plus 3. We are given the graph. So when we look at a graph, we should be able to easily identify the axis of symmetry because it's the vertical line that goes to the vertex. So our vertical line that goes to the vertex is right here. Or it's the line that cuts the graph in symmetric halves. So in this case, our axis of symmetry is x is -1. The vertex is at the point -1 for our x-coordinate, 4 is our y-coordinate. It crosses the x-axis. Our zeros are when x is -3 and when x is 1. You could put -3, comma 1, or x equals -3, x equals 1. Either one is acceptable. The y-intercept is at the point 0, 3. And if it's asking for the y-intercept, you just say 3. I'm okay with that. Sometimes they will want you to write as an ordered pair, but if it's asking specifically for y-intercept, I will accept just 3. Looking at this graph, does it open up or down? Well, it opens down. You can't fill it up. And if you look at it, our equation here has a negative in front. Our leading coefficient is negative, and so it's less than 0, which means we are down. Since we're opening down, the vertex is at the highest point of the graph, so this is a maximum. It's the highest point, so it is our maximum point on the graph. All the y values are at 4 or lower. And then we have to review some stuff we've done in the past, our domain and our range. Remember, domain is your x value, it's your inputs. So in this case, our x values, we can actually put in anything for x in this case. So our domain is all real numbers. Our range is our y values, it's our outputs. And if you notice that all of our y values are at the vertex or lower. So in this case, my range, my y values have to be less than or equal to the vertex, which is so our range is y is less than or equal to 4, because that is the coordinate from my vertex. So we use that for our range value. You guys might remember doing this when we did absolute value functions. When we had the vertex, we use that for our range value. All right, so that is all for 9.1 day 1. Today we talked about a lot of the vocabulary and the characteristics of a quadratic function. We looked at the axis of symmetry, we looked at the vertex, we looked at does it open up or down, we looked at if it's a maximum or minimum, we looked at zeros, and we looked at y-intercepts. Thank you for watching, and have a nice day.